Since the advent of neutrino physics, the Sun has been a very powerful astrophysical source of neutrinos for study. In this poster, I'll show some preliminary plots from a solar neutrino measurement in a new snow plus water dataset, and highlight the fact that this dataset is a very low background. Now, perhaps counterintuitively, it turns out to better understand what goes on in the core of the Sun, we must dig deep into the depths of the Earth. SNO+ is a neutrino detector located 2 kilometers underground in an active nickel mine in Sudbury, Ontario, in a place called SNOLAB. Boron-8 neutrinos from the Sun can be measured by identifying elastic scatter events in the SNO+ water phase data above a given energy threshold. We can perform an analysis to measure the neutrino flux and spectrum by exploiting the fact that these solar neutrino events will typically produce Cherenkov radiation directed away from the Sun, by bending events in this co-state of Sun directionally observable. We've previously published an analysis with an older 114-day lifetime dataset that showed an extremely pure electron scatter signal above 6 MeV, and performed a spectral analysis of the flux using a 5 MeV threshold. Now, subsequent to these results, we fully implemented a nitrogen cover gas system in the following operational period to reduce radon ingress into the detector, and an additional larger 190-day lifetime dataset was taken with even lower backgrounds than before. And here's some of the preliminary co-state of Sun distributions with this new data. This time at a 5 MeV threshold, there's a near background-free electron scatter signal using a comparably sized fiducial volume than what was used in the prior analysis. Just to highlight this point further for comparison, I've included on the right the co-state of Sun distribution from the previous dataset at that 5 MeV threshold. You can clearly see this reduction in backgrounds. Indeed, if we were to use a tighter fiducial volume cut, you can see that even in the 4 to 5 MeV bin, there's a resolvable solar signal. In this reduced fiducial volume, the data is a rather modest flat background contribution in the 3.5 to 15 MeV co-state of Sun. So what does this all mean exactly? The main takeaway is that these plots highlight the very low level of background events in this newly taken water dataset and suggest a very low energy analysis threshold is achievable in a forthcoming spectral measurement of the boron-8 flux with this new data. Certainly more broadly, these low backgrounds show a very positive outlook as the collaboration moves into and is currently continuing with its simulator fill phase.